Up to this point, we've been testing one proportion to see whether or not the proportion is greater than or less than the claim, but we can make it a little more generic and do a two-tailed test where we're just interested in if the proportion is different than the claim, regardless of if it's greater than or less than. Let's say it is claimed that 30% of households own exactly 3 smartphones. A marketing firm test this with 150 households. And found 43 of them own 3 smartphones. What can be concluded? If alpha equals 0.05. As with all hypothesis tests, we'll go through that same 6-step process to make sure we cover all the elements needed for a hypothesis test. The first is identifying the hypotheses. The null hypothesis is that our proportion, we're talking about a proportion or percent, so we use P, is equal to 30% of households owning these 3 smartphones. The marketing firm just wants to test to see if this is true. They aren't saying they think it's greater than or they think it's less than. So for our alternative hypothesis, we're going to just say that proportion is not equal to 0.30. So when we draw our picture, we've got our normal distribution with our mean of 0.30 in the middle. We actually would be OK rejecting if we ended up in the left tail or the right tail. So we'll shade both of them because we actually have a 2-tail test. We could reject on either side. In fact, we can figure out where we're going to label our sample on this by finding our p hat, our sample proportion, saying that 43 out of 150 houses seem to have owned the 2 smartphones. And if I do 43 divided by 150, we get 0.2867, which is smaller than the 0.30. So our sample ended up in the left tail, 0.2867. And now let's go through and calculate the actual test statistic. To find the test statistic, first we have to find the standard error, which we remember is the square root of PQ over N. P and Q come from the null hypothesis, so P is 0.30. Q is 1 minus 0.30, which is 0.70. And then we're going to divide by the sample size of the 150 households. And when I do this square root on my calculator, I get 0.0374. Once we know the standard error, we can actually calculate the test statistic, which is z. We know z is our sample proportion minus the hypothesized proportion divided by the standard error. So in our case, the sample proportion was 0.2867. We'll subtract the hypothesized proportion of 0.30. And we'll divide by the standard error of 0.0374. When I do that, I get negative 0.36 as our test statistic. Knowing our test statistic, then, we can use that on Excel to go back and calculate the all-important p-value. Now, this time, we are here in the picture on the left tail. So Excel will give me that left tail straightforward. I don't have to do any 1 minus because my sample proportion ended up being in the left tail. So I just have to type in equals norm.s.dist, my negative 0.36 test statistic, and true. And when I do that on Excel, I'll get 0.3594. But that on my picture is actually only representing the left tail. Because this was a two-tailed test, we have to remember that same amount, because it's symmetrical, 0.3594, is also on the right side. So to get the actual p-value, we're going to multiply by 2 to account for the left and right tail on my two-tailed test. And so my actual p-value is 0.7188. So using that to make my decision, we know that alpha was picked to be 0.05. My p-value ended up being 0.7188. Notice this time the p-value is larger than the alpha, 71% instead of 5%. With a larger p-value, we have not been successful in our goal of rejecting the null hypothesis. With a larger p-value, we have failed to reject. Let's just call it failed to reject. We'll put it in the present tense. Failed to reject the null hypothesis. And since I'm out of space, I'm going to move again up to this top corner just to finish it off. So for our interpretation, again, the interpretation always focuses on the alternative hypothesis. Because we failed to get the alternative hypothesis, we failed to reject the null hypothesis, we're going to say there is not sufficient evidence at the alpha equals 0.05 level to conclude the alternate hypothesis, the proportion of households that own a smartphone, that own 3 smartphones, is, the alternate hypothesis says not equal to or is different than 30%, or 0.30. Notice we did not say that we proved the proportion is 30%. We will never prove the null hypothesis is true. We can only fail to prove the alternative hypothesis is true, and our interpretation needs to be done in that context. Notice the only difference between failing to reject and rejecting on the interpretation is with failed to reject, we stick the word not in. If we had rejected, we'd remove the word not, but everything else is identical because it always focuses on the alternative hypothesis in context to the problem we're looking at.